Dear students, today we will learn the intervals which was left over in the last part. So we continue with set theory, we will learn the intervals. It's a very small part. So let us learn its concepts. What are intervals? So intervals, we have 4 intervals. So what are intervals? So let us see some example. Number 1. Sometimes when we say that x is between 2 and 5 and x is some integer, that means x belongs to z. So what is the meaning of it? It means that it implies that x will be equal to 3 and 4 because these two integers are within 2 and 5. Now this is the concept of interval. This is known as open interval. The above situation is known as open interval. It's open interval. And how do we write this? Instead of writing this thing, we write 2, 5 and it's a kind of first brackets. Okay, you can see rounded this thing. So it's a first bracket we write when it's a open interval. That means both the ends are open. So why it is open, that we will discuss a little later. First let us see the 4 intervals. Now if we get this kind of situation where 2 and 5 are inclusive at the both ends, so obviously x belongs to z. These will give us, the integers like starting from 2 to 5. So it will be 2, 3, 4 and 5. So that means we can write this x belongs to what? A different symbol. The square brackets we write 2 and 5. So this is known as the closed interval. Why it is closed interval? Because it's closed in the ends. Okay. Number 3 is a very interesting situation. When we get 2 lesser than x lesser than equal to 5. That means you see, still I write x belongs to z. Still I write x belongs to z. So that means it will start from integer 2 after integer 2 and it will end when it touches integer 5. That means x here will be equal to 3, 4 and 5. Are you getting? Since this end is equal to, we have included the integer 5 in the whole system. It's greater than 2, that's why we have not included 2, we have excluded 2 and we have started from 3. So here we write a mixed kind of notation. So this end is open, this end is closed. So we will write things like this end is a round, this end is a square. Okay, so this is known as a semi-closed interval, semi-open interval, or better to write open closed interval. Please note it, open closed interval. Now the 4th interval type you can guess. I'll just tell it to you. It will be a closed open interval. So just try to write or try to guess how will be the 4th interval. So if you can think a little bit, so pause the video and think of this closed open interval. So you will get it. Closed open interval. So you will get it. This side, that means the left hand side is closed and the right side is open. So still x belongs to z. Still x belongs to z and you can write you can include 2 this time, and 3 and 4. We have excluded 5. So how does it look? It looks like square on 2 and 5 will be open. So these are the simple intervals concept which we use in set theory. Just look at it. After that I will give you some example related to this. Now first let us discuss why it is known as open interval or something like that. Look at it. It has got a typical or peculiar openness. If we change the scenario, the first scenario, that means this thing, to x belongs to R. Okay, I'll write it x belongs to R. So just see, there is no end to the numbers. That means if you want to write x, what will be x equals to? It will be just right after 2. That means someone can write 2.001. Other people can also write even more closer, 2.001. So just look at it. The number line, if it is 0, say if it is 0, here there is a 1, 2 and there is say 5. So look at it. It will be something like, it's as close as possible. So it will start from, someone will say 2.01 and other people will say that it's much nearer, much closer, like 2.001. Again someone will argue that it's much more closer and closer. Even in this end also something like that, you can write 4.99, someone can write 4.9999, and it approaches as close as possible to 5. So that means it's never ending. So we observe a kind of openness. So that's why, because of this kind of situation or this kind of characteristic, it is known as the open interval. Whereas in this kind of thing, that means the second part, when you are actually seeing this thing, observing this thing, it's stopping right at 2 and it's stopping right at 5. That means if you take this 2 on the number line, this will be dark bubble, you know. That means it stops. So it's closed. So that is the peculiarity of this. Okay. Closed interval and open interval. One more thing about intervals. Very important thing rather. So what are intervals? Like we learned that set is a family. Okay. Set is a family. It contains many members. Okay. Or elements. So what are intervals? So intervals are nothing but, sets. It's a set of numbers. Just look at it, this thing. So it means this. So this 2 to 5 is nothing but 3, 4. Okay. Or you can say that this 2, 5 is nothing but 2, 3, 4, 5, right? So intervals are nothing but sets. It's actually the numbers which we write within sets. Now we will try to see how we use these intervals in set theory. So I will erase this. Now mainly we use the intervals when we try to describe the set builder form of representation. Now say we write a set where we write it's x such that x belongs to z, and what is the condition? It's x belongs to something like 3 to 9 open closed interval. Okay, that means this is the set builder form I have written. That means this set will be something like starts right after 4, after 3, because it is integer. So it will be 4, 5, 6, 7, 8, 9. Now you can see that using these intervals we have written a set. Okay. Many things can be written. So here we have used the open closed interval. Now if I want to write 2x plus 1, where x belongs to a whole number and x starts from, or it's a whole number, so I get it like this maybe. That means it will take up how many values? 5 values. It will take up 5 values, 0, 1, 2, 3, 4. So when you put a 0 over here, you get 1. When you put a 1 over here, you get 3. So this is the consecutive odd numbers you get, 1, 3, 5, 7 and 9. How do you get the 9? When you put a 4 over here, 4 2 is 8 plus 1. So this is 9 you get. So this is how the intervals are used in set theory. The next video we will continue with the other things of set, the operations mainly. Thank you for today.